Welcome to the video for Section E of the AP Calc Summer Packet. Section E has some review problems on factoring. Okay, you're not going to really have to factor anything ridiculous on the AP exam, but there are some tricks from Algebra 2 and Pre-Calc that we really need to have down pat, so when we do have to solve some polynomial equations, we can use the factoring that we learned in those courses. Okay, the most important thing, the first thing you should always look for when you're factoring something is your GCF. If you remember, those of you that had me in Algebra 2, I used to like to say that the GCF is your BFF. That's not just like a stupid pun to get everybody to laugh, though it usually does. The point is, the GCF is the most important technique and maneuver we want to look for when we try to factor something, because it helps us break the numbers down into smaller numbers. And smaller numbers are easier numbers to work with. So for instance, if I give you a polynomial like this, 6x cubed plus 2x squared minus 20x, and I ask you to factor it, the first thing you should look at, and the first red flag that should hopefully at this point go off almost instantaneously in your head, is that all the numbers are divisible by 2, and all the letters have at least one power of x in common, which means there's a GCF of 2x here. So we can take that out, and we'll be left with 3x squared plus x minus 10. From there, we just have to focus on factoring this part, which is a little bit easier. It's a quadratic. We can split the middle. We can think about what multiplies to negative 30 and adds to 1, and rewrite the middle term that way and go from there. So 2x times 3x squared. Instead of using x, I'm going to use two numbers that multiply to negative 30 and add to 1. So how about 6 and negative 5? So we'll do 3x squared plus 6x minus 5x minus 10. And then we can do some more GCF action. We can take out a 3x from the first pair, and we're left with x plus 2. We could take out a minus 5, and we're left with, x plus 2. Where have I seen you before? And then we can put that all together. We get 2x times the quantity 3x minus 5. That's my two outside terms, times x plus 2. And then that's completely factored. Can't go any further than that. Okay, so your GCF is your BFF. But then there's also some patterns that show up that really at this stage in the game you need to have memorized. So there's some also special patterns that we can use to factor things. Okay? The first special pattern is the difference of squares. So if you have two perfect squares, and you're taking the difference of them and you're asked to factor them, your factors are a minus b times a plus b. As in the example, 16x squared minus 25. 16x squared and 25 are both perfect squares, so they behave as the a squared and the b squared of your pattern. So a would be 4x, because if you squared it, you get the 16x squared of the original problem. B would be 5, because if you square it, you get your 25. So you just stick those into the pattern, and you get 4x minus 5, 4x plus 5. Okay? This should all be familiar to you. Another pattern that I know you learned for the first time in Algebra 2, and hopefully did some more work with it in Pre-Calc, is a sum or a difference of cubes. Okay? A cubed plus b cubed, or a cubed minus b cubed. Now, when I learn these and memorize them, I kind of memorize them together, because the 5 terms that I'm going to have, and if you remember, you're going to end up with a binomial times a trinomial, so there's 5 terms. They fit into a pattern, a nice little chant that I have memorized. It's AB, A squared, AB, B squared. AB, A squared, AB, B squared. The only thing you really have to remember is the signs. See, the 5 terms are the same whether it's a sum or a difference. The signs are different depending on the problem, and here's how I remember that. I remember the signs using the acronym SOP. Same, opposite, plus. So we do same as the problem. So for the sum, we have a plus first. Opposite the problem, we have a minus. And then always plus for the third term. So that's how you'd factor a sum of 2 cubes. For the difference, same thing. Same as the problem, so minus comes first. Opposite the problem, so plus comes next. And then third sign is always plus. So that's your two patterns. Okay, so for instance, if I ask you to factor 64x cubed minus 125, if we look, we see 64x cubed is a perfect cube. Its cube root is 4x. 125 is also a perfect cube. Its cube root is 5. So now I'm going to go into that pattern and I'm going to replace 4x for A and 5 for B and then use my SOP rule to figure out my signs. A, B. A squared, I'm going to stop for a second. When you square a product like this, 4x, you're squaring both the number, so we have a 16, and the variable, so we have x squared. AB, so that's 5 times 4x, and then b squared, and then we just got to fill in our signs. Same, minus, opposite, plus, and then plus third. That's your sum and difference of cubes rule. The last thing that might pop up is good old grouping. This one is when you're dealing with an even number of terms, usually 4 terms in a polynomial, and you're asked to factor it. So something like this, x cubed minus 8x squared plus 4x minus 32. The way we group is we take the first 2 terms, the second 2 terms, pull out a GCF. It's very similar to the split the middle approach that we use for quadratics. So for x cubed and 8x squared, I have a GCF of x squared. Pop it out, I'm left with x minus 8. 4x and 32, I have a GCF of 4. Pop that out, and we get x, minus 8. I know I did the grouping right because these match. I take the outside terms that I pulled out, the GCFs, pop them into one set of parentheses, and I'm done. X squared plus 4, x minus 8. Remember also, I should have said this at the outset of the video, but it should be common sense and second nature to you at this point. You can always multiply your factors together and you should get the problem back and you know you did it correctly. Okay? These are the tricks that in my opinion, are the most important factoring tricks for the course this year. So they're the ones that you're going to see in this section of the summer packet. Now, there might be more than one of these tricks in a single problem. That's why you should take your GCF out first. You might have a problem where you take out the GCF, and then you end up with a summer difference of cubes or a difference of squares or so on and so forth. All right? So use these tricks to do the problem in the packet, and thank you for watching.